Hello dear student. Now today we are going to discuss few more details about this topic electric potential and capacitance. Already last few lectures we discussed electric potential due to dipole. If a point lies on axial line of dipole, so we got one derivation and formula. If a point lies on equatorial line of dipole, we got a formula. Now general case I consider, point lies somewhere, it made some angle, okay, so that time how we consider electric potential formula. This formula is very important. Dear student, if you observe this definition and if this derivation up to end, definitely you will get how we got that axial formula is like that and how that equatorial formula is 0. These two things we'll get clearly by using this derivation. So focus carefully. Next, case 3. Electric potential at a point which lies an angle theta, which is lies at an angle theta with dipole. Electric potential at a point which lies at an angle theta, lies at an angle theta with a dipole. For example, let us consider a dipole. You know already, dipole means equal in magnitude opposite charges separated by some distance. Am I right? They are separated by some distance. Is this distance is equal to 2a. Now somewhere I consider here is a point P I consider. Am I right? So now join this point and charge. Okay. Join point and this charge. Okay. So now just draw some imaginary line, join the point and line. This is called what? Let us consider this is a point O. Distance from point O to P is called R bar. So assume that this is a point, a midpoint of this dipole. Assume that this is a point, midpoint of dipole. Okay. So this is a point, a midpoint of dipole. Okay. So this is a point, midpoint of dipole. Let us assume distance from minus Q to point P is some R1. Distance from plus Q to point P is some R2, you can assume. Now if you draw the perpendicular line to this Q charge, plus Q charge, that means these two are now equal. If you observe this carefully, then these are what? These two are so equal in distance. Now what about this distance? So total distance is R1. I want this distance. This distance is definitely, total is R1 and this is R2. Then what we will get here? R1 minus R2. Okay. This distance is R1 minus R2. Okay. So this distance is R1 minus R2. Let us assume this is some point C. Then this is what? Perpendicular. Definitely this is 90 degrees. Okay. So now what is this? This is a dipole. Okay. It made some angle theta with the dipole. If you draw any line, this is called some R from O to P. You know that if you solved nearly here two cases, in that two cases also, distance from center of dipole to point is called R. Right. So Observe diagram carefully. AB distance is equal to here 2a. AB is nothing but a distance of dipole, that is equal to 2a. And AP distance is equal to R1. AP is equal to R1. BP is equal to R2. OP is equal to R. OP is equal to R. This is the distance from center of dipole to a point. And AC distance is equal to R1 minus R2. AC distance is equal to R1 minus R2. So we need to find net potential at point P. Net potential at point P. Dear student, observe carefully. Here two charges are there, plus Q charge, minus Q charge. Minus Q charge acting some potential at point P. This plus Q charge, due to this plus Q charge, some potential is acting on P. So that means we need to find potential due to minus Q charge, potential due to plus Q charge. What is potential due to minus Q charge? You know potential formula. Potential V is equal to 1 by 4 pi epsilon naught into Q by D. This is general formula. Electric potential due to point charge formula, you know. 1 by 4 pi epsilon naught into Q by D. Here Q means charge. D means distance from point to charge. I am talking about electric potential due to minus Q charge. That means 1 by 4 pi epsilon naught. What is the charge here? Minus Q. Minus Q by distance from point to charge. The distance from point to charge is what? R1. R1. Next, we are talking about plus Q charge. That means 1 by 4 pi epsilon naught. What is the charge here? Plus Q. Distance from point to charge is R2. Observe diagram carefully. Here D is nothing but distance from point to charge. Distance from point to plus Q charge is what? R2. R2. Next, if you common these values Q by 4 pi epsilon naught, then we will get here 1 by R2 minus 1 by R1. 1 by R2 minus 1 by R1. From this, Q by 4 pi epsilon naught R1 minus R2 by R1 into R2. Okay, so this is a net potential at point P. Net potential at point P. Okay, so net potential at point P, if it is lies at any angle, this is a general point. Net potential at point P is equal to Q by 4 pi epsilon naught into R1 minus R2 by R1 into R2. So now observe carefully. This is a special case. If P lies far away from dipole, P lies far away from the dipole, then R1 into R2 value is approximately equal to R square, and R1 minus R2 value. Observe carefully. R1 minus R2, how to find this? So from this diagram, if you consider right angle triangle here, this is right angle triangle is this is 90 degrees. At 90 degrees, what is the point? C point. And here is here theta means definitely here also angle theta. So here also angle theta. Then this is a theta. Then we consider nearer to C. Here is a point theta. Then we'll get this is A. This is at A angle theta is there, A, and this is B. Observe carefully how I draw the diagram here. At a C, 90 degrees is there. That's why I indicate at C. At A, theta is there. Here angle theta means here also angle theta. Here angle theta means definitely here also angle theta. These are corresponding angles. According to mathematics, these two are corresponding angles. Then at A, angle is theta and this is a B. From this, observe carefully. A BC we don't know, but AB value we know. What is AB value? AB value is 2A. And AC value we know. What is AC value? R1 minus R2. So I want R1 minus R2 value. Apply cos theta. Cos theta is equal to adjacent side by hypotenuse. Adjacent side is R1 minus R2. Hypotenuse is 2A. Then we got R1 minus R2 is equal to 2A cos theta. 2A cos theta. So dear student, observe this formula and substitute whatever the values we got here. We net at a point P, at any point, if point P lies anywhere, at any position, at any angle to this dipole, this is a general case. If you know this formula, if you are easy to solve, that means potential due to axial line, potential due to equatorial line, all values easily get by this formula. Observe carefully. V net at P is equal to Q by 4 pi epsilon naught into R1 minus R2 means 2A cos theta. 2A cos theta. And R1 into R2 means nearly R square. So from this we got, this is a standard formula, 1 by 4 pi epsilon naught. 2A into Q is nothing but P. P cos theta by R square. This is V net at P. Net potential at point P. Net potential at point P. So this is a very important formula. So this is net potential at general point due to dipole. Net potential point at general, net potential at general point due to dipole. The formula is what? 1 by 4 pi epsilon naught into P cos theta by R square. Very important formula. So please note down this. Then you will get clear idea now. By using this formula, we can apply every case. Any point, we can apply electric potential due to dipole. We are easy to find by using this formula. At any place. If point lies on axial line, if point lies on equatorial line, if point lies on some angle 30 degrees, 60 degrees or any position, we are finding easily by using this equation. What is that? 1 by 4 pi epsilon naught into P cos theta by R square. This is the formula. So I hope all of you understood. Now observe carefully. So I will finish this. So what is the formula we got finally here? 1 by 4 pi epsilon naught into P cos theta by R square. P cos theta by R square. P cos theta by R square. Observe carefully. This is a potential due to dipole for general case. By using this case, we'll get all three cases. Up to now, three cases we discussed now. Potential due to general point. Potential due to general point. Formula what we got? 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. P cos theta by R square. We got formula. P cos theta by R square we got.